In this last video for today, we're going to take a look at evaluating function notation in multiple representations. So that means using tables, graphs, and mappings, or any other form that we could find a function in. So taking a look at this first graph, we see a lot of discrete data, separate dots. So if I name this a of x, I solve for a of -6. So again, this -6 is replacing the x value, so that's telling me that x equals -6. So I'm going to make a note of that here. X equals -6. So if that's true, I'm going to go along the horizontal axis to -6, and then I notice that there is a dot up here at 3. So that means it's the ordered pair -6, 3. So my output is 3. So that's my answer. If we look at the second problem, a of x equals -2. So that's basically like saying the output or the y value is -2. So that means we're going to look at our y-axis, our vertical axis. If I go down to -2, I see that over here there is a dot at 5. -2 is the ordered pair. And so that means that my x value is the input 5. So that's looking at discrete data on a graph. If we look at continuous data on a graph, notice every point is connected. So we're calling this function b of x. If I solve for b of -9, again, that's inside the parentheses. It's telling me my input is -9. So if I go to -9 over here, I notice that there is our starting point at 3. -9, 3 is the ordered pair. So my answer for the input of -9, my output would be 3. And here it's telling me my output is 7, or my y value is equal to 7. So if we look along the y-axis, here's 7, and the only dot that reaches that high is at -7. All right, yep, that looks right to me. So -7, 7. So again, if our y value is 7, we're looking for our input, our x value. So x is -7. All right, and this next problem, we have, I named it c of x. So the first thing that we're trying to find is c of 2.3. So it's saying our x value is 2 3/10. That's our input. We'll look under here where it says x. So we see we have 2.3. That's our only one because this is a function, because it doesn't repeat. And so we have our answer here is 3.4, or 3 4/10 is our output. For this next problem, it's telling us, well, this is the output value is 2.3 now. So here it was the input value inside the parentheses. Now it's telling me, well, we should get 2 3/10. So that's our output. So we're going to look under this column where it says c of x, and we find 2 3/10. That's nowhere else. So now we look and we see our answer is 3 4/10. So kind of flipped them around there. So here we're going to say our x value is 3 4/10, because that's what we didn't know. That's what we were trying to solve for. In this last section, we see we have a mapping here. So we have our input values x. This function is, we're naming it d of x. So here's our output values. And so if we look at this first part, we have d of 9. So it's saying our input value x is 9. So if we go down to underneath x, we go down to 9, we see there is an arrow pointing to 5. And remember, it's okay to have these other arrows pointing to 5 as long as 2 arrows are not coming out of one input, because that would mean that, like, if we had -2 going to 4, that means it could go to 5 or 4. We never want that. We don't want 2 arrows coming from the same number. But so here again, our output is 5. So we have d of 9 equals 5. And here again, it is mixed up, and now it's giving us our output value. So if we go under d of x and we see 4, we can trace the arrow back to 3. So that's saying our x value is 3.